Happy Asynchronous Wednesday. Us teachers don't like that word asynchronous. Why? That means we don't see you, right? All video lessons and stuff like that. Anyway, you get to see my hand. Woohoo! Okay, let's go with it. You know the drill. I have included a copy of this as an attachment if you want to try to print it out so you don't have to copy these down. Otherwise, press pause, copy all these down, try to do as much as you can do. Come back for hints if you want. I will get some hints in some of this. And then press pause whenever you need to go finish and come back and check your answers. Okay? All right. Welcome back, everybody. Hopefully you did well. Okay, things I can give you a hint on. If you want a hint, I'm going to give you a hint right here and say your hint is 4. Okay, I'm going to give you a hint here and say it's a dozen. What is a dozen? Okay, well, a dozen is 12. Okay, what's strange though is what they call a baker's dozen is usually 13. What does that mean? If you go to the donut shop and ask for a dozen donuts, they will usually throw one in free because you bought 12 of them. Right, so a baker's dozen is 13. I don't know if Happy Donuts does that or not. Hint here is 8.4. That's your hint. What does that mean? 8 is one of the numbers. Your hint here, what two numbers multiply together equal 32 and add together equal 12, because I'm pretending there's no decimal. 4 and 8 work, right? That's your hint. That's not the answer, though. All right. Hint here. 2 times what is 4? 2. 2 times what is 40? Okay, you can finish that. 4 times what is 120? Well, 4 times what is 12? 3, right? So 120 will be 30. Okay? And at that point, you can almost get them all, right? I still have to figure out this one last outside number. 30 times what is 2,400? Well, 3 times what is 24? 8. I had 2 zeros there, so I'm going to need a 0 here. So I have 84 times 435 on this one. What was the original problem for this one? 22 times 12. Okay. Don't forget how you solve these, right? You got to do these exponents first, then get the sum. Do these exponents first, then get the difference. Okay? All right. You can press pause if you want to go work some more. And if not, we're ready to finish up all the answers. 4 times what is 36? 4 times 9. That's 2 squared, and that's 3 squared. 12 times what is 36? 12 times 3, and 12 times 3 plus 3 is 15, right? 8 times what is 32? 8 times 4, and this ends up being 8.0 if you want to add a 0, and 0.4. Much more common to add a 0 in front of a decimal. Okay, I think one of the things it does, it draws your eye to that. You don't usually have numbers that start with 0. So if you have a decimal in front of it, putting that 0 there really sort of, it puts a spotlight on the fact that, hey, why do I have a 0 there? Oh, there's a decimal, right? Okay, same idea here. If I have 0.24 or 4 tenths plus 8 tenths, I end up 1 and 2 tenths when I add. And when I multiply 8 times 4, remember we pretend there's no decimal? And then really, to pretend there was no decimal, I had to move this over one spot here and move this over one spot there. That's a total of 2 spots. I move it over 2 spots to the right so I can pretend when I come back to reality, got to move it 2 spots back to the left. Okay, that's why that works. Good. 20 times 10 is 200. 2 times 10 is 20. So I have 240 40 and 20 and 4, add them all up. 264. If I did the standard algorithm, I have 2 times 22 is 44. Put a placeholder because that's really a 10. 1 times 22 is 22. When I go add 264, look at that, same answer. We must have done it right. You know that we made mistakes twice, right? 8 times 4 is 32, but I'm going to move the decimal over 3 spots, so I end up with 32,000. 4 times 4 is 16, but I'm going to move the decimal over 2 spots, so I get 1,600. 4 times 30, oh, that's already done. 8 times 5 is 40. Then I move the decimal over 1. Sometimes people make mistakes on this because they see that 0 and say, oh, I've already added a 0, right? So make sure, especially those numbers where the product ends in a 0, if you need to move the decimal over after that, you do that. 4 times 5 is 20. So my addition problem here, 32,000, 2,400, 400, 1,600, 120, and 20. So 40 here, how many hundreds? 7, and 8 is 15. How many thousand? 3, 5, 6, 36,000. And when I estimate that, I have 80 times 400, 32, 30. So my estimate ends up being this, right? Okay, get me close. And that's one of the reasons this generic rectangle is kind of cool, because that upper left-hand corner is you're multiplying the biggest value digits, right? 4 hundreds, and the biggest value in this one is 8 tens. So that quickly gets you pretty close. It's always going to be smaller because you haven't added the other rectangles. All right, standard algorithm. 4 times 5 is 20. Carry the 2. 4 times 3 is 12 plus 2, 14. Carry the 1, right? 4 times 4 is 16 plus that 1 is 17. Put a placeholder because that's really 80. And since I have some carry marks there, I want to get rid of those, cross them out. I don't erase them, but I cross them out so I don't get confused when I have more carry marks, right? 8 times 5 is 40. Put the 0 there, carry the 4. 8 times 3 is 24 plus 4, 28. And 8 times 4 is 32 plus 2 more, 34. Could have used a little bit more room here, huh? And the 3, 36, 540. Good. We did it right. Okay. All right. 3 squared is not 6. It's 3 times 3. 4 squared is not 8. It's 4 times itself. 4 times 4 is 16. And 5 to the second power is not 10. It's 5 times 5. So that's 25. And 9 plus 16 is also 25. So these two equal. Isn't that cool? 3 squared plus 4 squared is 5 squared. Something later on you're going to find out is called a Pythagorean triple. Okay, 10 squared is 10 times 10, not 20, 100. 6 squared is 6 times 6, 36. And 8 squared, 8 times 8 fell on the floor. I picked it up. It was 64. What's the difference between 136? Well, guess what? Isn't that cool? 64 equals 64. So I have equal again. 13 squared. You know that one? That's 169. 12 squared is a dozen. That's also known as a gross number. I'll explain that one to you later. We'll have fun with it. And 5 squared, we already figured out is 25. What's a gross number and 25 when you put them together? Oh my goodness. Are all of these going to be equal? Oh, 3 to the 4th power. That's 3 times 3. How many times am I going to multiply 3 by itself? That many times. Okay? And this is 4 times itself 3 times, right? I can say this is 9, and these two make a 9, and 9 times 9, 81. These two make 16, and 16 times 4 is 64. So now I have one that's bigger. 3 to the 4th power is bigger than 4 to the 3rd power. Remember which way is it going to point? Always points at the smaller number. Okay, 5 to the second power is 25. 2, such a small number, it's got to be smaller, right? 2 times 2 times 2 times 2 times 2. What are we going to end up with here? 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 2 is 32. That's bigger. It's going to point to the 5 squared, right? Another way of doing this, again, you can do it all sorts of ways. Let's say those two make a 4. These two make a 4. I still have that 2. This 4 and 2 makes 8. And 4 times 8 is 32, right? All sorts of ways. 6 to the third power, 6 times 6 times 6. 36 times 6, that's 6 30s, 180. That's 6 6s is 36. And I end up with 216 here. Now 3 to the 6th power, I can say that's 9. Those two make another 9. Those two make another 9. 9 times 9 times 9, it's not 27. 9 times 9 is 81. And you can do this in your head. 9 80s, 72 with a 0. 9 1s. So this ends up being 729. Big number. Big number. Much bigger than the 216. So we're saying left hand less than. Good job. Good luck on your science quiz. And have fun doing those graffiti worksheets. We will see you soon.